The first question is about to prove that the minimum distance for any point in the Nyquist plot to -1, 0 is 1 over ms, where ms is the peak value of the sensitivity function. Okay? And the second one is about the phase margin and gain margin. Its lower bound is related to ms. Okay, so let's start with the first one. Okay, the first one. Now we're trying to see what is the distance between Lj omega and -1, 0. Well, an easy way to see this is by giving a plus of their coordinates. It's by -1, and this should be writing minimum Lj omega plus 1. So this is a distance between Lj omega and -1, 0. And we take the minimum of this. This is supposed to be 1 over ms, but we have to prove that, right? So what is ms? Well, for ms, it's the peak value of the sensitivity function, and it's the maximum of 1 over 1 plus Lj omega. Right? So what is 1 over ms? This is 1 over the maximum value of 1 over 1 plus Lj omega. And this one, consider you take a 1 over on the maximum of a certain value. You can just, for the insider one, you can get 1 plus Lj omega. Right? And what is outside of this? Well, I believe this should be it should be minus of this, since previously it's a maximum one. So if we take a 1 over it should be minus as a minimum one, right? Okay, so we can notice that these two parts are the same. So it proves that the first one, the minimum distances from any points in the Nyquist plot to the -1, 0 is equals to 1 over ms. Okay, so let's start with the second problem. The second problem is to prove that the gain margin is greater or equals to ms divided by ms minus 1, right? So let's recall about something about the gain margin. Where do we represent gain margin in Nyquist plot? Well, let's first draw a Nyquist plot. Well, but this is a Nyquist plot. This is -1, and if the crossover point of the Nyquist plot to the axis is point A, then we name this distance as 1 over gm. In other way, the coordinates of A should be written by -1 over gm dot 0, right? Remember, there's a point, for example, point B on the Nyquist plot, that has the shortest distance between -1 and this point. And this distance should be 1 over ms, as we proved before. So in other words, we have an inequality equation like this. Inequality like this, 1 over ms should be smaller or equals to the distances between point A and -1, 0, right? So let's remain 1 over ms smaller or equals to. How to represent this part? Well, from the figure, we can easily set that the distance between -1 and 0 should be 1 minus 1 over gm, since the distance between 1 and the origin, -1 and origin is 1. And this is 1 over gm, so it's easy to see that. So it's the 1 over ms is smaller or equals to 1 minus 1 over gm, right? let's rewrite this by putting gm on the other side. 1 over gm, smaller or equals to 1 minus 1 over ms, and rewrite it by replacing 1 with ms divided by ms. So this is ms minus 1 ms, and finally we got gm is larger or equals to ms divided by ms minus 1. So the second one, check. Let's go with the hardest part. Okay. First of all, we notice that there are two inequality here. Oh, sorry, it's arcsine. Arcsine 1 over 2 ms larger equals to 1 over ms. Okay, there are two inequality here. Well, let's first prove the second one since there's only one parameter there, but there's a PM there. Okay, 2 arcsine 1 over 2 ms larger or equals to 1 over ms. Let's put 2 in the other side. Arcsine 1 over 2 ms larger or equals to 1 over 2 ms. This can be written by sine 1 over 2 ms smaller or equals to 1 over 2 ms. Okay, here's the interesting part. A sine something, let's call it x, is smaller or equals to x. Well, is this obvious? Of course, if you take the Taylor expansion of sine x, it should be writing x divided by x cubed divided by 3 plus So as far as x larger or equals to 0, this relationship stays. Because ms, of course, is larger or equals to 0. So this one proved, right? So the second inequality has been proved. Let's go for the first one, which is the hardest part. PM larger or equals to 2 arcsine 1 over 2 ms. Right? The similar method, let's go through what is phase margin in Nyquist plot. Okay, we have a Nyquist plot. We have a -1. To see the phase margin, we first need to draw a unit circle and take the crossover point. Maybe again we call it A, but I mean it's a crossover point to represent the phase margin, and this point is phase margin. Okay, so similar as the first one, now we consider about 1 over ms is still smaller or equals to the distance between A and -1, 0, right? Well, from this perspective, how to represent this one? Previously, we got the coordinates of A. Now, let's try to get one. We only know the radius of A and the angle of A, so we use a phasor representation. A equals to 1 with an angle of minus 180 minus phi m, right? Because this is 180 minus phi m, and since it's clockwise, so we got the minus sign there. Okay, so let's represent A equals to 1 over phi m minus 180, and it's same as cosine phi m minus 180 if we take the complex coordinates plus j sine phi m minus 180, right? And you know, if there's a 180 inside a cosine or inside a sine, you can simplify it by minus cosine phi m, in this case, minus j sine phi m. Okay, now we got the coordinates of A. What do we do next? We find the distance between A and -1, 0, right? Again, it's similar as the previous one. We just add a 1 on the x x part on the real part of a. So now the distance should be written in 1 minus cosine phi m. Remember, this is a plus, minus j sine phi m. And what is the absolute value of this, right? It's root 1 minus cosine phi m squared, the square is outside, plus the sine phi m squared, right? And if we trying to simplify that, we will have 2, because 1 here, 1 cosine phi m squared plus sine phi m squared, minus 2 cosine phi m. And we need to prove that this one is larger or equals to, oh no, we don't have to prove this. This is what we have already proved. Now we got this, we need to prove this. Wait a minute. There's a sine here, but a cosine here. And there's a root here, but there's no root here. How's that possible? Like, we can't just ignore the root or change the cosine to sine. So how do we do that? Well, let's go from here. Go from the beginning. Now, phi m, which is pm, divided by 2 is larger or equals to arc sine 1 over 2ms, right? And if you both take sine phi m divided by 2 is larger or equals to 1 over 2ms. Wait a minute. Here, the face margin has been divided by 2 with a sign in front of it. Well, if I can divide the face margin by 2, remember this cosine 2 theta equals to 1 minus 2 sine theta squared. This is some theorem in triangular function. If you don't remember this, I believe it's hard for you to solve this, but yeah, I hope you remember this. Okay, so in here, if we change 2 theta into phi m, we can find that cosine phi m equals to 1 minus 2 sine half of the face margin square, right? And we substitute this into this, and now we have, if these 2 are cancelled and there are only 4 sine half of the phi m squared, larger or equals to 1 over ms. And if we rewrite this, 2 sine 2 phi m squared, there's no square, greater or equals to 1 over ms. And if we divide by 2 in this should be sine phi m divided by 2, larger or equals to 1 over 2 ms, which is exactly the same as this one. Okay, so the second problem also checked. So during this process, you can figure out that most of the time we're trying to use plot to see what is exactly the gain margin and face margin. And more interestingly, we can find that MS can hold, if you got the MS of a certain control system, you can get the lower boundary of the JM and phi m, which somehow helps you to identify two of the most important features in a control system, which is face margin and gain margin. So I believe MS is somehow important, and if you get this, it helps you to identify a lot of things. So you will get used to it in the future.